All right, CNBT 1342, building codes and inspections. Let's look at exam number 1 first. Here's exam number 1. As you'll see, the exams are all in D2L, and they go in order of the chapter. So chapter 1, here's the first question. Chapter 2, next in the question. Chapter 1, third question. This is all out of the book. Same with chapter 2. Same with chapter 3. Same with chapter 4, 5. And this is fill in the blank right out of the book. I even did you a favor and left what the icon means. Okay? All you got to do is fill it in. Fill in. This is right out of the book. I can't make this any easier. Building codes can be as boring it's like watching paint dry. Okay? Now, let's go and get into the book. Okay, you are going to need this book. There is no way around it. I just showed you the exams. They're all the same. They're right out of the textbook, right off the video, because the video goes through the chapters. If I've added something to my PDF, it's because it's something you need to know. So here's the textbook. You need it. Again, I put chapters 1 through 6 in D2L. That's my Christmas present to you, because I know you students are going to walk the dog and not get the book up front. You will need the textbook, period, bottom line. That's all I'm going to say about it. There will be 23 chapters that we will go through in 5 weeks and 2 days. Yes, 5 weeks and 2 days. All right. The preface of the book. This is intended to give you, an aspiring building designers, a basic understanding of the use and application of the International Building Code, the IBC. It's not going to make you code experts. It won't make you building inspectors. It takes 2 years at least minimum for a building inspector to get his or her feet under them. And there are many kind of inspectors: electrical inspectors, plumbing inspectors, HVAC inspectors, you name it, access and egress inspectors. All right. Now let's get into chapter 1. Now, just like I showed you on the exam, there are answers to the exam questions in order from the first part of chapter 1 all the way through the back page. So, 4,000 years ago in Babylon, there was the code of Hammurabi, and it decreed death penalty for a builder of a house if he constructed it and it collapsed and killed somebody. All right. There have been designers and architects and engineers that have had criminal charges brought against them because they violated the code or the specifications and something bad happened and people died. The Hyatt Regency Sky Bridge collapsed on New Year's Eve many years ago, probably before most of y'all were even born, happened. And there were some people that went to jail over that. And that didn't, and then there's the lawsuits. Okay? All right, now, why do we need licensure of design professionals? Well, it's simply the protection of the health, safety, and welfare of the public. Sounds like another answer to a question, doesn't it? Mm-hmm. Yes, indeed. Okay. The IBC. What is the IBC? It's the International Building Code, the IBC. Okay. What's the ADA? Americans with Disability Act. You have to satisfy that code. You can find all this online. What is the FFHA, the Federal Fair Housing Act? Okay. You can read all of this on your own. All right. Now, states and localities will also have different building codes. They will take the IBC and they will add to it. They won't take away from it, but they will add to it. Now, Who controls that? Who polices that? Okay. Well, your local authorities that have jurisdiction, your building inspectors, and you and them will work together. So you have state building codes, you got local building codes. Jersey Village has a different one. Fort Bend's got their own. Harris County's got their own. City of Houston has their own, etc., etc., etc. Now there are others. The National Fire Protection Association, all right? Fire codes, NEC, National Electric Code, or International Electric Code. Then you got the plumbing code. You got local, state plumbing codes. Then if you're a pressure vessel engineer, there's AISC, American Institute of Steel Construction, ACI, American Concrete Institute, etc., etc., etc. If you're doing pressure vessels, you got the American Society of Mechanical Engineers Pressure Vessel Code. Then you got ASHRAE that deals with HVAC work and refrigeration. Okay. Then you got your health codes, like for hospitals and stuff like that. Okay. Now, we have rating systems, and we're trying to balance life safety versus property protection. The safety of life is number one. Property is number two. As you will see through this code, we're mostly dealing with fire, right? And the smoke that comes from the fire. Well, that's for the protection of human life. All right. Now, how do we navigate the code? Let's go into chapter 2. All right. If you're following along with your exam, you will see that we're going to talk about the intent of the code as opposed to the interpretation of the code. Designers also have intent. All right. And do not try and ignore the code. If you do, you're going to set yourself up for a very, very sad situation. Approvals by the authorities having jurisdiction. Okay. Will help you, quote unquote, interpret the intent of the code, because they're the ones that are going to sign off on it, or they're going to red tag your project. All right. Okay. So what is meant by the intent of the code? That's the letter of the code. The code's written by people. The intent is what they intended the code to do. Now you have interpretation. So intent versus interpretation. So intent plus interpretation equals intent, equals intent, equals intent. You violate this, somebody gets hurt or killed, you're going to be in a world of hurt. Don't do it. Okay? You get with your local building code people. Authorities having jurisdiction, the AHJ. These individuals' view of the intent can lead to alternative interpretations of the code compliance. Okay, what's alternative means and methods? Well, it's right here. Now you see this little gizmo right here? That little funky monkey looking thing. Okay, 104.11. If you Google this, go IBC 104.11, you're going to find the code. You'll find it. Okay, you don't have to go buy the giant freaking library. So alternative means and methods means the designer gets with the AHJ, okay, your code people with your jurisdiction, and come up with alternative means of fireproofing, say a structural steel framework, columns. All right. Here we have an example of it encased in concrete. Here we have it sprayed with a spray on fireproofing gypsum, and here we have it wrapped in special sheetrock, not the crap you get at Lowe's or Home Depot. Okay. All right, and we'll get more into that later, all right, as we go through this course. All right, so this is alternative means and methods. And the index in the back will help you find where these definitions are, okay? Okay, so let's look at intent versus interpretation. All right. No, I just got ahead of myself. I'm sorry. Let's go back down here. All right. Code interpretations. All right. So if you, the designer, view or interpret a code different than the local AHJ, whose final decision is it? Because both the designer and the AHJ are working to apply generalized code provisions. You're working together. So you want your project approved to be built. You don't want to be under construction and all of a sudden somebody says, oh, the interpretation's not right. Okay? The interpretation doesn't satisfy the intent. Then you get red tagged. Then the contractor is going to charge you more money. Okay? So you have to balance the intent with the interpretation or an alternate means to satisfy the code. You get that in writing and you're good to go. Okay? Now there are 9 major code components, okay? 9 major code components. Using the code components. See? Even the questions are tied to that section of the chapter, code components. So what are the 9? Okay, well, here they are. Occupancy type, construction type, fire extinguishing systems, it could be passive or active, building or floor area, your building height. Okay, there's 1, 2, 3, 4, 5. All right. Exits and egress, that's 6. Fire protection again, okay. That's extinguishing, but what about protection? That's 7. Building separations and shafts, that's 8. And your engineering requirements, that's 9. Okay, code components. Okay, all right. Code analysis. Okay. Every project, no matter how small, should have a written code analysis included in the construction documents. That means your construction documents and your specifications have been reviewed by the authorities having jurisdiction, the AHJ, and they've signed off on it. They have approved it. Do not try and memorize parts of the code. Okay? This stuff changes. Always go back and check it. The safest thing you can do is have early meetings early on with everybody. The project client, the AHJs, your engineers, everybody. And do not think your code official is going to do your work for you. You must know this stuff. Okay? All right. That is chapter 2. Wow, wasn't that fun? Here's chapter 3. Wow, we're moving right along. Okay. All right. Let's go up here to the start. It would always help to go up here to 1. There we go. Chapter 3, occupancy classification and use. There are 10 basic occupancy classifications. Okay? The IBC establishes the following occupancy classifications. See how easy the exam can be if you have the book. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the letter designation, A is for assembly, B is for business, E is for education, F is for factory, H is for high hazardous, I is institutional, M is mercantile, R is residential, S is storage, and utility and miscellaneous is used. See how easy that is? And again, here's one of those funky monkey classification numbers you can go look up if you want to. Now, on down through the occupancy groups. See, occupancy classification. Wow, okay. It talks about the definition of each one of these assembly groups. What really is an assembly? And what do you got to do? Okay. All right, let's move on. Here's business group. There's many different types of business groups. Educational groups, hazardous groups, factory groups. All right. Now, what's a control area? What's a control area? Control areas are spaces within a building where quantities of hazardous materials not exceeding the maximum allowable quantities per control area are stored, dispensed, used, or handled. Okay? Wow. All right. Why do we need control areas? The control area concepts, it allows for multiple use of the building. So you can have people doing all kinds of stuff in here that have nothing to do with the control material in the control areas. All right, and these control areas are designed for the fire suppression and exhausting of anything in case you have a fire in there or whatever substances are stored. Does that make sense? All right. All right. And this talks more about control areas if you want to get down into that. So, why do we need control areas? It's to separate the areas of a building for multi-use of a building, house people, activities, etc., and separate the humans in the hazardous areas and activities. Plain and simple. Okay. All right. And it goes on and talks more about, more about your institutional group ones and all your different groups. You can read down through here if you want. But that ends the testing section for Chapter 3. But let's say you're in a design project. Keep this book. It'll help you go back through it, and it'll go you the code, and so you can go research that section of the code. Isn't that special? Okay. All right, special detail requirements based on occupancy and use. Okay. There are two major steps that you have to go through. Okay. This is step 1, and this is step 2. First, you figure out what your group assembly is. Okay. And then you have to identify what's in this chapter 4. All right. Then you refer to this. What's happening in my assembly or my business or my education or my factory? What's happening? What's happening? Okay. Now, this is a list. There may be a higher list with your local building codes. So don't get all, thinking this is the end all do all. Okay. So there are two major steps. First, to identify the general use, and then two, you go to the the special requirements, detailed requirements based on the use of the occupancy. That make sense? All right, let's move on. Okay. Covered in open mall buildings. Okay. Covered in open mall buildings. All right. What is a covered mall building? What is it? Well, it's defined in here. A covered mall building is a roofed or covered pedestrian area into which two or more tenants have their main entrances, right? Okay. There's your definition. All right. Covered malls are governed by these provisions and are limited. All right. Whereas as an atrium, it's covered under this section. All right. Now, what's an anchor building? Look, see, we got an anchor building here. All right. What's an anchor building? We got an anchor building down here. It talks about what it is and what it isn't. Okay. Here we have something about an anchor building. Here we have not considered to be a part of the covered mall building. Open space, separation of distances. You can read all this on your own. A building or housing any occupancy having low or ordinary hazard contents and having direct access to a mall structure, but having all required means of egress independent of the mall concourse. So you don't have to go in the mall concourse to get out of this anchored building. Okay? All right. That's the definition of an anchored building. All right? Now let's move on. What's the next important one? Okay. Now we get into high-rise buildings. What's the definition of... Go down through. See, there's a bunch of stuff in here for covered mall buildings. See, here's high-rise. Now we go to high-rise buildings. Look at that. High-rise buildings. Okay. All right. What's the definition of a high-rise building? Okay. Definition of a high-rise building, the definition of a high-rise building. I can't make this any harder. Well, I could make it harder, but I can't make it any easier. How's that? All right. Now, what's the definition of a super high-rise building? Okay. You'll find that in here, aka World Trade Center. Right there, 420 feet for super high-rise. Okay. All right. And then 75 feet for a regular high-rise. All right. And note the criteria determining if the building is a high-rise is measured to be the highest occupied floor, not to the height of the building construction, and not to an occupied roof. See, this is an occupied roof. In other words, it's like a tennis court or overlook area. Okay. The occupied floors have a ceiling and walls around them. Okay. So this would be like 75 feet. Okay, if it's super high rise, it's 420 or above. All right, and this is sort of based on the largest ladder truck height from the fire department. I mean, because to get up into here, they can't use the ladder. They got to go inside the building, go up stairways or whatever to go in there to suppress the fire. All right. Okay. Alrighty then. So it's from the lowest point to what? To the highest occupied floor. Right? Okay. Alright. Dun 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 dun. Now we go to atriums. Atriums. See the question on the test about atriums? Oh, atriums. Look at that. So what is by definition an atrium? Is an opening that connects two or more stories in groups 1 through 2 and 1 through 3 occupancies, and 3 or more stories in all other occupancies. In other words, it's considered to be the interconnected series of floor openings inside the building that create a physical connection. All right, so it's a giant opening all the way out of the sky, the roof, right? Okay. All right. And how is fire or smoke handled in an atrium? Well, let's read on down through the book. Anium, there's a fire here. Okay, so we have a fire. We got fire suppression systems, sprinklers, right? Those would be active, okay? And we have exhaust. We got to be able to remove the smoke exhaust, okay? Because the fire, here's your fire load down here, burning plastic carpet, I don't know, witches, whatever. And the gas and smoke has got to get out of this atrium. If not, it's going to filter into these floors and start poisoning people, right? So we have to have a smoke exhaust fan to suck all that stuff out, all right, along with the fire suppression system, all right? That's how smoke is handled in an atrium. Now, motor vehicles. These are parking garages, all right? So, how must parking garages be separated from the mall? The answer's in here. It's in the book. How are they to be separated? You got to separate them. I mean, you don't want the mall to blow up, right? Okay. So, all right. So, connection of a parking garage, which would include residential parking garages, okay? So, what about motor vehicle stuff? Private parking garages and carports, all right? Minimum clear, all right? It means of a vestibule providing a two-door separation with exceptions. Okay, here's a vestibule, all right? Parking garage in this section should be read as applying to both public parking garages and enclosed. So here's a door, and here's a door, and there's a vestibule separated with a fire-rated wall, mostly concrete, most likely. Okay, so vestibule with two doors, one to the parking garage and one into the building is required per this section of the code. All right? And this is to prevent non-combustible fuel flames from entering the adjacent space. Just seal off this area. All right? Okay. Now we want to talk about open parking garages and closed parking garages. Here's the definition of open parking garages. Okay. Tells you the ratio of the openings, and the idea of an open parking garage is that you have a lot of area for smoke and the fire to escape out the sides. The World Trade Center during Bill Clinton's administration as president, the Taliban, Osama bin Laden, tried to blow it up by parking a van full of ammonium nitrate, diesel fuel. We call that AMP. And inside the open parking garage. Well, they didn't do their engineering calculations very well, because when the van blew up, the blast wave, instead of going up, found the least resistance, and the blast wave went out all the openings side to side, tore a bunch of cars and stuff, but did not collapse the building. All right. Yeah. And they later put their little brains together and figured out they crashed planes into them and that eventually collapsed them. And they did because of the bundled tube concept. The steel got overheated and just couldn't support the upper floors. So, too bad, because it was a really unique design. And those of you who saw the video in Cnbt 1311 class that I did understands how it was done and the bundled tube concept. Here is the definition of an enclosed parking garage. By the very definition, it's enclosed. You don't see any of these openings around here, right? So it's going to have what? It's going to have an active fire suppression system, aka sprinkler system. It's going to have ventilation in, and it's going to have exhaust out. Right? You don't see a whole lot of these around. You drive around Houston area and see how many open parking garages versus enclosed. As you can probably already determine, these are much easier to design and cheaper to build, right? Because you don't have to worry about all the other suppression systems. And repair garages fall under a different part of the code. All right, so let's move on to chapter 5. Let's move on to chapter 5. Let's get our little drawing thing set up. Let's move on to chapter 5. All right, building heights and areas. Okay. So, what do we want to focus on here? What is a building area? What is a building area? Okay, here's your definition right here. Definitions. Building area is the area included within surrounding exterior walls. This is generally interpreted as meaning the inside face of the exterior walls. see the commentary at the left. That would be over here. Okay. So what we're talking about is a 2D, okay, two-dimensional. 2D area is always 2D. Oh, that's an ugly looking D. 2D. So exterior walls. This inside here is your building area. All right? Okay. All right. Our air vents. What about air vents? Vent shafts are excluded from the building area. Vent shafts are excluded. So are vestibules. All right? Okay. Areas included within the horizontal projection of a floor and roof above. All right. So, what about basements? Okay. All right. What about basements? This is what a basement is. Okay. Everybody knows what a basement is. All right. Here's the definition of a basement. It's found in here. Okay. And how you calculate the basement. If it's part of the basement, if it's not, is it a story or is it a basement? And here is the definition of, is it a part of the story or not? Depending on your grade line, your finished grade line, okay, for your basement. And that's found in here. All right. How's your building height calculated? We talked about the height of a high rise or a super high rise or whatever. Okay. So, how is it determined?
Was on the form. Yeah.
Did I miss that? Have I already missed it? I think I've already missed it. I think I've already missed it. I think I scrolled too fast. Oh my goodness, my apologies. My apologies. My apologies. My apologies. There it is. My goodness. Wow. Okay. Your building height. Wow. I'm getting way ahead of myself. The building height is the vertical distance from the grade plane to the average height of the highest roof surface. Okay, the grade plane. All right, the grade plane. All right, the grade plane is this. It's a reference plane representing the average grade levels along the exterior walls of the building, the average. And then you'll come up here, and it's a vertical distance from the grade plane to the average height of the highest roof structure. Okay, the height of the highest roof surface. Okay, there it is. All right, does that make sense? And what's a story? What is a story? And we already talked about that with the basement, right? That's back up into here, the story. So my advice is that you look, those definitions are up in here for a story, okay? The occupiable or usable space located inside the building, contained by a floor below and a roof structure ceiling above. All right, we found that here. So here's a story. It's occupiable use space. Okay. Okay. There's a story height. Okay. So these are stories. What's a story? The occupiable usable space located inside the building. It's got a ceiling, it's got walls, and a floor. All right. That's why a basement's a story, but not a story. Okay. All right. And how is a story measured? Okay. It goes back up in here. Your story height is measured as the vertical distance. Okay. From the finished floor to the finished floor of the next to the adjacent story. All right. A mezzanine. What's a mezzanine? Yeah, I got ahead of myself. I apologize. Is an intermediate floor level. So this would be a mezzanine. You got stairs coming up. Here's a mezzanine section. Calls out mezzanines and equipment platforms, perhaps. Okay. Could have people on them. This one could have people. Well, it's ugly looking people. Okay. It could be a doorway going back into the deal. Okay. When an intermediate floor meets the criteria and is considered to be a mezzanine, the floor level is not considered to be a story. It does not contribute to the floor area. All right. So when you're looking at floor area, if you've got mezzanines, you can check this section. All right. All right. And the area is generally limited. It tells you up into here of 1/3 the floor area. All right. Okay. Let's see. Okay.
Or the next time we go live, because
All right.
even if we're not doing anything on our side,
Okay. Let's see here. What's next? What is the designation of NS? All right. NS buildings. Building heights and designations. All right. Here are all your building designations. All right. These are very, very important. N is not equipped throughout with an automatic sprinkler system. NS, no sprinkler. Okay. No sprinkler. NS. S, it's equipped with an automatic sprinkler system. How about S1? Okay.
well, how are we going to
S1, maximum of 1 story above the grade plane and equipped throughout with an automatic sprinkler system. SM, buildings 2 or more stories above throughout with an automatic sprinkler system. And an S13R equals buildings equipped throughout with an automatic sprinkler system installed in accordance with National Fire Protection Association in Group R occupancies up to and including 4 stories in buildings not exceeding 30 feet in height above or below fire vehicle access. All right. And the S13D is rarely used, so they didn't analyze it here. And I didn't ask you about that on the exam. So look at all these free exam points that you just got in the book and by watching the video. All right, that's why I'm doing the videos, to guide you through this, because there's a lot of stuff in this book that I don't expect you to read unless you're just really geekoid into this stuff. Now, we got to find out what a live-work unit is. There are units called live-work units. See, you can go through and beat yourself up by going through all this stuff, right? And we don't want to do that. There's no reason for that. All right. Mezzanines and equipment platforms. This defines mezzanines even more. And if I'm not mistaken, the 1/3 requirement is in here someplace, but that's all right. Let's see here. What is a live-work unit? Live-work unit. Live-work unit.
So I was explaining to
My
But
goodness.
it's much bigger than that. And I was explaining to
See,
them,
there's a whole bunch of stuff in here,
what we've been
man.
trying to accomplish with the Cnbt project and standing up that database with an audit trail. I said, I think some people
This
are
could be
concerned about deleting
a
data.
multi-semester study, right?
Because we don't
Area modifications,
have
there's a formula to modify areas. Again, you get back with your authorities having jurisdiction, and sit down with them and go through all of this. Okay, mixed use occupancies. Okay, that means we have what? We've already talked about mixed use occupancies. All right, all right. Live work units, mixed use occupancies, live work units. The most traditional live work apartments place the living quarters above the business space, but that's not always the case. The living space may also be alongside the commercial space or behind it. Live work units are distinct from traditional residential spaces in that they are explicitly designed to accommodate both living quarters and professional workspaces with the same footprint. All right, and here's some of your requirements for your square footage. So this would be a residential area, okay? So some require the sprinklers, right? Because you've got commercial activity. All right. It talks about your vertical egress in here, and then we'll talk about egress and access in another chapter. All right. So that's your live work unit. Okay. It's a mixed use occupancy, residential and non-residential, mixed together. Okay. All right. Now, to finish off our first week exam, we have the layout of the code. Places table 5901 after the text for a section. Do not confuse table 5008.4 regarding occupancy separations with the incidental use table. As examples, we have highlighted the incidental uses most likely to be encountered in a building design. Okay. So, if you have this in your mixed unit, any of these, okay, or a mixture of them, okay, electrical installations and transformers, then here's the requirement that they have to have. All right. And as you can see, since you've already printed out your exam and you're following the video with the exam, all right, this is the back part of your exam. Look at that. It goes back over here, all right? So, this is straight out of the book. You know, fill in a bloody blank, right? Bloop, 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 bloop. And where do you get this information? Oh my gosh, right over here. So, y'all should be able to make an A on this thing. I mean, seriously. You should be able to make an A. Because all of this, it's just, it goes in the spot on the exam, right? Okay, all right. I don't think I can make this much easier unless I filled your exam out for you. And this says a special thing on special provisions. All right, so for week 2, we'll start off with chapter 6, types of construction, and I'll get off into some geek land over here as an engineer, but you'll survive it and enjoy it. Okay, that's enough for now. I think it's enough for now. Wow, this video is only running 44 minutes. That's pretty good. I thought it'd be longer. Some of them may get longer. We got a lot of moving parts in some of these, but I will try to make it as painless as possible. Again, print the exam out. Print the exam out as you before, okay, and go through the video and the book. Have the book and watch the video. You can stop and start the video. It'll be on YouTube. Okay. All right. We'll see how this works. Try to make this as painless as possible. Try to make this as painless as possible. All right, we'll see you on the next one.